Hello, and thank you for joining us for another exciting day of the Veterans Advanced Energy Week. My name is Jennifer Gordon, and I'm the Managing Editor and Senior Fellow for Nuclear Energy at the Atlantic Council Global Energy Center. I will be your moderator for this session. If you were not able to tune in yesterday, you will be able to check out all the content on the Atlantic Council YouTube channel following the conference. Yesterday focused on the big picture, and we heard about energy and environmental justice, energy access in conflict zones and developing countries, and the geopolitics of the energy transition. Today, we will be focusing on the energy technology trends that are poised to shape our future, from energy efficiency to offshore wind to the topic of this conversation, advanced nuclear technologies. I am pleased to be joined today by a group of esteemed experts as we discuss next generation nuclear technologies, their implications for national security, and the policies that can speed their commercialization. Before we get started, a few housekeeping notes from me. This event is on the record, and we are currently live streaming on Twitter, Facebook, and YouTube. We encourage you to post about what you hear today and share on social media using the hashtag VetsInEnergy and by tagging us at AC Global Energy and at Vets_energy. If you would like to participate in our conversation, we encourage you to submit your questions in the Q&A portal located at the bottom of your screen at any time during today's event, and we will incorporate your questions as appropriate. Please note, however, only those directly engaging via the Veterans Advanced Energy app will be able to submit questions. Finally, I'd like to mention the phone-based app for this conference, which is a great way to network with everyone here. The app also includes a resume submission feature and a virtual cafe where you can find out which companies are here and recruiting veterans for civilian jobs. Turning now to the topic of this panel, at the Atlantic Council, we've talked a lot about nuclear energy and national security, and we've placed a lot of emphasis on the importance of the United States regaining its role as the global leader in nuclear energy exports. With major recent developments in advanced nuclear technologies and many more on the horizon, it's all the more critical that countries, whether they are entirely new to nuclear or perhaps just new to advanced nuclear, look to the United States for civil nuclear supply and finance. We have an outstanding panel to delve into some of these issues. First, it's an honor to introduce Dr. Rita Berenwald, who is the Assistant Secretary for Nuclear Energy at the U.S. Department of Energy's Office of Nuclear Energy. Dr. Baranwal will set the scene for our panel discussion today.
Great, thank you. Can you hear me okay, Jennifer? Very good. After 5 months of doing these webinars, I've learned to at least ask that before we embark. I want to thank all of you for attending the Atlantic Council's Veterans Advanced Energy Week, and I want to send a special thank you to Jennifer for the invitation to speak here today to you. While many of you are aware of nuclear from the Navy and defense perspective, I want to discuss with you some of the exciting updates from the commercial nuclear energy industry and its benefits and importance to our energy needs, economic prosperity, and environmental sustainability. First, though, I wanted to share my story of how I ended up in nuclear energy. It was very much thanks to the Navy. My degree in doctorate school was material science and engineering, and I started to embark on looking for jobs. And lo and behold, a headhunter who was looking for a position at Bettis Atomic Power Laboratory contacted me. And I ended up working at Bettis for almost 10 years, developing advanced nuclear fuel for our Navy's aircraft carriers and submarines. What really clinched it for me to stay in this industry, though, was on a very serendipitous trip, transporting a bunch of summer interns down to Newport News shipyard, where I had the privilege of standing inside what would be the reactor compartment of the Ronald Reagan aircraft carrier as it was being built, and realizing as I stared several stories up that the tiny little fuel that I was working on back in Pittsburgh was going to eventually power this behemoth of a ship to help defend our country. And that was a turning point for me, recognizing how important nuclear energy is, not only to the defense of this country, but also for energy security and for prosperity. And so I view nuclear energy as crucial to ensuring the sustainability of our environment now and into the future. Nuclear energy is this country's largest source of clean, reliable, and resilient electricity, generating about 20% of the electricity in the US and over 55% of our country's clean energy. US nuclear reactors operate with a capacity factor of over 93%. That's the highest of any reactor fleet in the world and the highest of any source of electricity. In 2009, electricity that was generated by nuclear in the United States avoided the release of over 476 million metric tons of CO2 into the atmosphere. That's the equivalent of removing almost 100 million cars off of the road. Many countries also see nuclear energy as a means to meeting their energy demand and growth, supporting their clean energy goals, and providing energy diversity and security just like we do. I'm confident that the United States nuclear energy technologies can and will play a major role in providing the United States and the world with clean and reliable energy for decades to come. Nuclear energy is revolutionary beyond just electricity generation, though. It can provide low emission energy for water desalination to achieve worldwide water security. It can decarbonize the industrial sector with process heat. It can also decarbonize the transportation sector with hydrogen and electrification. Just recently, we awarded $9.2 million in a funding opportunity announcement for a pilot program at the Davis-Besse Power Plant in Ohio to generate hydrogen, not only for its local manufacturing operations in that area, as well as its bus fleet in Toledo. So the very poetic use of nuclear energy all around for that community. And also nuclear can be used for the betterment by way of medical applications and space exploration. Just recently, I had the honor of being able to attend the launch of the Mars 2020 rocket, which launched all the way to Mars. It's on its way now. The radioisotope thermoelectric generator that's going to be used to power the Mars rover. So again, a very unique use of nuclear being used for space applications. New advanced nuclear reactors have the potential to solve the diverse challenges across our nation as well as across the globe. In my office at the Department of Energy, we're focusing our efforts around 4 major priorities. The first is to sustain our existing fleet of nuclear reactors. The second is to get advanced reactor technologies over the finish line with a sense of urgency. This is one of my top priorities. The third priority is to establish and maintain the critical fuel cycle infrastructure that's needed for a robust set of nuclear reactors. And the fourth is to enhance the global competitiveness of the United States. In April of this year, the President's Nuclear Fuel Working Group released its report entitled Restoring America's Competitive Nuclear Energy Advantage, which lays out policy options to restore America's leadership in nuclear energy and technology. The report recommends continued support for the demonstration of U.S. advanced nuclear technologies. My office took action by launching the ARDP Advanced Reactor Demo Program. This program focuses DOE and non-federal resources on the actual construction of advanced demonstration reactors that are affordable to build and to operate. The ARDP funding announcement closes next week on August 19th, and we look forward to reviewing the applications and moving toward demonstration. We're also strongly supporting the National Reactor Innovation Center, also known as NRIC, to enable these demonstrations and the development of the Versatile Test Reactor, VTR, we love our acronyms, to ensure that we have the infrastructure necessary to support the long-term success of U.S. advanced nuclear technologies. In the global marketplace, superior technology just isn't enough to compete with other countries that can provide comprehensive build and operate packages with attractive financing and fuel take-back options. That's where we really need to make some progress. We need to be able to compete with these comprehensive packages. A fully functioning Ex-Im Bank is certain to help, as will the U.S. Development Finance Corporation, DFC, which is finally able to support nuclear energy projects and provide private financing. These recent changes will surely make a difference. Providing comprehensive fuel management solutions can also help. We're moving forward to ensure that the U.S. regains its nuclear energy leadership, building upon the United States leadership in innovation and advanced technologies. This will not be easy, and it will require a lot of work. In particular, if we want to achieve these aggressive goals by 2030, I am very confident that working together, we can address these challenges that face nuclear energy to meet a wide range of needs in a low carbon future. I thank you very much for your dedication to this important issue. I thank you for your service, and I look forward to a lively discussion in the next panel.
Thank you so much, Assistant Secretary Baranwal, for these insightful remarks. It's great to hear a little bit of your career story from the beginning, your experience with the Navy, and to now learning everything that your office is doing. It was wonderful to have you join us today. So now, in turning to our panel, I'm delighted to introduce Dr. Rachel Bronson, President and CEO of the Bulletin of the Atomic Scientists, Chris Colbert, Chief Strategy Officer at NuScale, Jackie Kempfer, Senior Policy Advisor at Third Way, and as of last week, a non-resident Senior Fellow at the Atlantic Council Global Energy Center, and Eric Williams, Vice President of Engineering at TerraPower. So without further ado, I'd like to jump into the first round as moderator's prerogative. But please, to those of you listening, please use the Q&A function at the bottom of your screens and jump in and submit your own questions. So we're here to talk about advanced nuclear technologies, and NuScale is obviously one of the leading companies in the field. So Chris, could you please give us some background on what we mean when we talk about advanced nuclear, and tell us a little bit about what NuScale is doing?
Okay, can you hear me okay, Jennifer?
Yes, we can.
All right, great. As again, following the Secretary's lead and checking to make sure that I haven't rambled on for 10 minutes before I realize I'm on mute, which sadly has happened in the past. So first, I do want to give a shout out to the Department of Energy. We've been in a partnership with them as NuScale, developing and licensing our technology over the last, really, I would say 20 years when we started with the small program, but more seriously over the last 7 years, where private investment of about $650 million partnered up with $350 million from the Department of Energy has brought NuScale to where we are on the verge of getting a design certification from the Nuclear Regulatory Commission. Also want to say that while thanking them, also say that for the Department of Energy and for my own company, the views here are my own. So take that with a grain of salt and don't hold the parents accountable for the acts of their children kind of message here. So on the advanced reactor, there's a lot of discussion about what really is an advanced reactor, whether it's based upon fuel type, size, how it's intended to be used, or frankly, what people say in their marketing material. Being a private enterprise, we're no different from that sort of tendency, as everybody wants to make sure that they espouse that they are the most advanced of the advanced reactors. But really what I look to and try to avoid that conflict is really talk about the definition that comes out of the Nuclear Energy Innovation and Modernization Act, which was passed a couple of years ago, where they look at the attributes of what they're looking for in an advanced reactor, whether it be additional inherent safety features, lower levelized cost, lower waste yields, greater fuel utilization, enhanced reliability, increased proliferation resistance, increased thermal efficiency, or ability to integrate into electric and non-electric applications. So in that act, what they're basically saying is that if you have a react case is really the AP1000 under construction in the United States, you need to be significantly better than that in order to qualify. And with regard to what NuScale has done, I think we really stand out demonstrably in 3 areas, and arguably we hope to do on a 4th one. The 3 areas I would say that we really have moved forward on are safety features, reliability, and ability to integrate into electric and non-electric applications. On the safety side, we have what we call the triple crown of safety, which means that we can safely shut down an operator plant with any operator or computer action without any additional water or without any power, AC or DC, in the plant or outside of the plant to safely cool all 12 NuScale power modules in the event of a loss of power. We've also eliminated 2/3 of the safety systems and components over a typical LWR design, so it's much simpler. And as a result of that simplicity, we've greatly improved the reliability and our core damage frequency as measured by our PRA, probabilistic risk assessment. We're just on internal events, we're looking at a core damage frequency of something in the order of once every 3 to 4 billion years, or once really in Earth. We've also expanded in terms of our seismic criteria by going to a 0.5 G ZPA, zero period average, for our bounding condition. and the potential to have, depending upon the safety case, a site boundary emergency planning zone because of the low likelihood of an event, or because of in the event of an event where there's a release, by the time you get to our site boundary, it's not harmful to people or to the environment. On the reliability side, we've looked at what's caused reactor scrams in the fleet operating history. And because we've eliminated 2/3 of those systems I've mentioned, what we find is that we've eliminated about 75% of the causes of scrams in the active fleet. So if you don't have an emergency diesel generator, or if you're not reliant upon off-site power for safety, those things don't cause you to scram your site. So that, again, is a measure of safety that we see available to us, and reliability, because clearly as you scram the unit and bring it down, bringing it back up takes time and takes away from your reliability. And then finally, if you look at the fact that we have 12 independent modules, each one can be operated independently. So one can go down for refueling while the other 11 continue to operate. That also improves reliability, and the fact that for a part of the plant, we can start achieving 6 nines reliability to provide to adjacent loads. So important aspect in that one. And then finally, on the ability to integrate into electric and non-electric applications, we've done a number of archived publications on desalination, hydrogen production, partnering with oil refineries and doing load following. All those things are something that we can do given the size of our modules, given the safety case available to it, making that possible, and given the fact that the modules are themselves independent. You can have some applications being used for hydrogen production, you can have some just doing electricity, you could have some doing desalination. So in one case study we looked at, we could do provide water and power to a town of about 350,000 people, based on a case study we did down in Carlsbad, California. So, those are all things that we're doing. So, there's a lot of discussion as to what is advanced. We've taken a definition of what we think it means, and we've tried to compare it and really go out in the literature, and as well as in our safety analysis with the NRC, to demonstrate how you meet those requirements and show that to a level of satisfaction, and not only for the regulator, but for your customers and for the market generally. And importantly, as we're challenging this and doing with the NRC and providing that means of doing so, it provides a real advantage for technologies, other advanced nuclear technologies in the United States that will go through a similar process, because really having that seal of approval from an independent regulator such as the NRC is something that really comes to the forefront in demonstrating you've met those criteria that show that you are truly an advanced reactor. So hopefully I didn't ramble too long, but I'm happy to take any other questions on NuScale as they come up.
Thank you so much, Chris. And I think, one of the key things as I'm listening to your description of advanced reactors is knowing, not only are these really a game changer, I think, for energy domestically, but also internationally. So I'd like to draw a line from advanced nuclear technologies to U.S. national security, and for us to look into why international civil nuclear cooperation, as well as civil nuclear exports, play a key role in U.S. national security strategy. So, Eric, from your perspective at TerraPower, could you share some thoughts on these questions?
Yeah, sure, Jennifer. The first thing that I think of with regard to that question is just the history of the mutual support between the nuclear energy technologies used for strategic defense, as well as civilian nuclear energy. And if you look at any timeline of nuclear power history in the United States, you see some key events that happened in the 1950s, with 1954, when we had the first nuclear powered submarine, the USS Nautilus, and then followed 3 years later by the first commercial nuclear power plant in the US shipping port. And what that did was it set up the commercial nuclear industry on the path of using a solid technology that had been developed for the use by the Navy, and also established a lot of the safety culture that we're thankful to have in our commercial nuclear industry. And so there's always been this relationship of mutual support, and I think it continues today. When I look at our situation today, though, I think we're almost in the reverse of the Nautilus, the shipping port scenario, where now we've had some amazing commercial nuclear innovations that have developed in private industry, and they have the ability to be leveraged now for national security. And so I think that relationship of mutual support is still there and is very important. And the unique benefits that nuclear technology brings has always had, which the high energy density that it has, the high reliability and high efficiency that have been mentioned already. And these have now been harnessed in new ways to meet modern energy needs and can be leveraged to play a role in national security strategy. So one of the first areas that I think of in this area is infrastructure. You know, it's very clear that electricity is a key enabler of critical U.S. infrastructure. It powers the economy. Many U.S. government operations and Department of Defense operations actually depend on the grid and depend on it being reliable. Actually, growing up in South Florida, you know, with all the hurricanes that pass through the area, I was very familiar with the disruptiveness that is caused by these major climate events. And one thing that I don't think is talked about all that much is that nuclear plants are actually already hardened against external hazards. Not only do they bring that high capacity factor that Dr. Baranwal mentioned, but they also are hardened against, you know, major climate events that we expect to become more frequent in the future. So if you have an important strategic asset that you need to have power for in a secure way, nuclear can definitely provide that for you. Another one of the modern developments has been the use of micro reactors, small scale nuclear power plants that have extremely long fuel cycles. So they can be used to power remote operations and forward operating bases for the military. That's actually not a new concept. There's actually a lot of those types of reactors that were looked at by the US Army very early in our history. And now we're looking at that again in the context of advanced reactors that can actually bring more performance to the table. And then lastly, I'd have to mention data centers. You know, we look at use of nuclear power for securely providing electricity to data centers that have to run with a high rate of reliability. And nuclear power is a perfect application of that. And so if we have this vibrant civilian nuclear energy industry, including international cooperation, it creates the demand for that strong infrastructure. And that supports the current fleet of operating reactors, as well as the development of advanced nuclear reactors. The other part of your question was with regard to civilian nuclear exports. And that's a huge area. You know, there's all the data is telling us there's a huge market for advanced nuclear technologies in the 21st century. It's estimated to actually be in the hundreds of billions of dollars over the next 10 years. And we would certainly like to play a big role in that. So how could that also help us, reach our national security goals as well? And I've been privileged to have a lot of conversations with people in different countries around the world and talk to them about what their needs are for energy. And one of the things that I've noticed comes up a lot is they look at the United States as the gold standard, the Nuclear Regulatory Commission in terms of regulation. And so to the extent that we can supply them with their energy needs, we can form these long, multi-decade strategic relationships with these other countries and actually pass along those, high standards of energy safety and security. And so being part of those conversations is another strategic goal of the United States. And I think if we increase our exports and relationships with these countries, we can really strengthen that. And then the last point was just, and it's probably the most important for national security, is maintaining our technical leadership, because we can't be a part of the export equation and we can't be a part of the infrastructure unless we have credibility in terms of our technology. And so I think it's important to invest in regaining that leadership in the United States. Everything I just mentioned is enabled by that leadership and innovation. And this is really where the United States shines and always has, is in the area of innovation. And so one of the things that's key to that is actually to demonstrate our advanced nuclear technologies in the United States. And I'll give a shout out too to the Department of Energy and the Advanced Reactor Demonstration Program, because that's a key way for us to establish our leadership in the world and demonstrate these reactors in the US. And then the last part of that is just the workforce and the supply chain that also develops strongly once you start demonstrating this technology in the US. So we'll also increase, the competency of our workforce and regain some of our supply chain that we had years ago.
Thank you so much, Eric. And I definitely want to pick up in a few more minutes on the workforce and supply chain issues that you raised there at the end. But for now, I'd like to go back to your point on the United States having a seat at the table when it comes to nuclear exports and ensuring that we're exporting our safety and non-proliferation standards as well as our technology. It seems that we really cannot talk about nuclear energy exports, though, globally, without having some understanding of the arms control regime that's allowed the development and exchange of civil nuclear technologies while also providing safeguards against nuclear proliferation. So, Dr. Rachel Bronson, I'd like to turn to you. Could you talk about the framework of agreements that has enabled international nuclear energy and any concerns that you have about the future of the arms control regime, and why it matters, especially as we face now not only the existential threat of proliferation, but also that of climate change?
Thank you, Jennifer. And thank you to the Atlantic Council. Thank you to you, Dr. Gordon. Thank you, my co-panelists, for this opportunity, and those attending. I'm really glad to be here with you today. And there's a lot in your question, Jennifer, and hopefully we'll have a chance to come back to it. Because we are facing two existential threats on this planet of nuclear risk and climate change, I think we need to have a really serious question or conversation about how they intersect. And they intersect directly on this panel, directly on this conference, right? Which is that if you were looking at just the challenge of climate change, and it's very reasonable to do that given the challenges we face, there is no question that we need to have a whole of government effort to advance nuclear power. We have no choice but to advance all different kinds of energy sources, especially clean energy sources, and think about how we can get them all moving in the same direction, because there's a very energy thirsty global population out there and an environment that is struggling to keep up with it given the technologies that we're using. So what the Assistant Secretary said at the beginning about the hundreds of millions of cars were able, kind of equivalent to pull out the exhaust fumes we're able to pull out of the atmosphere because of some of these technologies, something we need to really take seriously. So climate change alone provides us a wildly important reason to focus on this conversation that we're having today. That being said, the other existential threat that we face is nuclear risk and the threat of either an exchange or especially an exchange due to an accidental use. That's something that we focus a lot at the Bulletin of the Atomic Scientists about misperceptions and the lack of safeguards currently in place to prevent a kind of escalation. And so on that front, I would say there's a lot of reasons to be concerned about where we are on the nuclear security side, right? And so when I think about the landscape that we have in terms of nuclear security, I think of three different blocks of time. We have the unabashed arms race between the US and the Soviets from 1945 to about 1970. We have what I would call the golden age of arms control between 1970 and 2010. And then we're in the current environment, which I would say is a return to a very dangerous period of an arms control 2.0. So what are those what happens during those time periods to create kind of this block? So when I talk about 1945 to 1970 is the signing of the NPT, the most important kind of arms control, foundational architecture in terms of arms control. And it lays out three kind of key points, right? That nuclear countries with nuclear weapons will try to reduce them. The second leg of the stool is that the states who don't have nuclear weapons won't pursue them. And the third is that every country has the right to peaceful nuclear energy. And that was built in 1970. Between 1945 and 1970, this was, the beginning of the nuclear age. There wasn't in the beginning these kinds of arms control agreements. That there was nothing really constraining the U.S. and the Soviets at the time. Other countries were becoming very intent on nuclear weapons. Between 1970 and 2010, we have this series of really important arms control agreements that are particularly between the U.S. and the Soviets, who have still to this day control 90% of the nuclear weapons on this planet. And a real effort to build that infrastructure and try to increase transparency and verifiability and bring other states into the arms control agreements to try to increase transparency and verification, as well as reduce their own desires for nuclear weapons. What happens in 2010 is it's the signing of New START, and it's really the last major arms control agreement between the US and the now Russians. And between 2010 and now, we have a couple of things happening. We have huge investments being made. It was before 2010, but really I would start at 2010, of huge investments now being made by every major nuclear power in their nuclear arsenals. We have a complete breakdown in the arms control infrastructure, if you will. And the last remaining arms control agreement between the United States and the Russians is set to expire, New START, in February 5th of 2021. So right after this coming election, which means this election is really important. What we've seen is a real stepping away by parties, the Russians, the US, and others, an unwillingness of Chinese and others to join in certain agreements. And so I would say we're in a period of breakdown. Why does all of this matter? Why am I giving you that really quick history? You have on the nuclear security side a real concern about the collapse of international agreements, the collapse of those agreements that enhance verifiability and reliability, the ability to trust but verify. All of that has really collapsed. At the same time, you have this huge need for civilian nuclear power. So my concern on this is that we should not be moving to advance our protection on one existential threat by raising the risk of another one. And these two, when it comes to nuclear power, are somewhat in conflict. Unless we can refocus on rebuilding a 21st century structure and architecture around arms control. And so my message to this community here, as many of you will head into the nuclear industry, is it's very important for us to think very seriously and understand the role that you and we all have in advancing a 21st century arms control regime that deals with many of the uncertainties that the security experts are so concerned with, so that we can move forward more quickly and bullishly on advancing nuclear power, not only in the United States, but around the world to address climate. And so there's a real coming together and a need to advance nuclear security on the defense and security side so that we can feel confident that states that are pursuing nuclear power for that many of their own reasons, that we are able to say with assurances that we know that they're advancing their civilian commitments rather than creating a weapons program on the side. And if we can rebuild that confidence, we will have a lot easier time doing all the things that that my co-panelists have talked about. And Jennifer, you and Bob Eichhorn talked about so elegantly in your report a couple of years ago from the Atlantic Council, that we have to think of arms control and the advancement of arms control, transparency and efficiency and all that's built into it if we want the kind of nuclear future that I think many of us are talking about today.
Rachel, thank you so much. It's just such an amazing call to action, and really setting up the stakes of why this matters so much, both on the technology side, and then also going back to what you call the golden age an arms control regime, and how that kind of underpins the safety for us all, but also our ability, I think, as you said, to counteract climate change. So, we've hit on a number of notes on why advanced nuclear technologies matter, from providing a reliable source of clean energy to advancing international civil nuclear cooperation to exporting U.S. safety and nonproliferation standards. However, when we think about U.S. government policies that support nuclear energy, what I think we see often are a lot of moving parts. And Dr. Baranwal really gave such an excellent overview of what a number of those parts are. And I think, kind of jumping off of her remarks, it's incredible to think about how much has changed, even just in the last year or so, from nuclear energy legislation moving on the Hill with truly bipartisan support to the U.S. Export-Import Bank being reauthorized, and just very, very recently, the U.S. International Development Finance Corporation, the DFC, lifting its ban on nuclear energy finance. And I should also mention, just last week, we heard testimony on the Hill on the American Nuclear Infrastructure Act. So, Jackie, I know you probably follow all of these developments more closely than just about anyone else that I can think of. So what I want to know is, can you tie some of this together for us, but also, tell us what's next on your policy wish list? What would you like to see implemented next?
Sure. And first, I'll also just thank you all for having me here. I'm really excited to be part of this discussion today. And I just want to jump off of some of the things that Rachel mentioned, which I thought were just so perfectly stated when we sort of look back at the sort of arc of our history of this intersection of risk. When we talk about peaceful uses of nuclear technology and sort of the arc of the arms race over the past many decades. And the reason that I want to build on that at first is because what I've been seeing over the past year or so is really exciting developments in nuclear security and safeguards and nonproliferation experts really engaging with the advanced nuclear developers from a very early stage. And this is something that I have been working on with colleagues at the Nuclear Threat Initiative and Atlantic Council over the past year and a half to really try to break down some of the sort of strong silos that have existed between these communities over the past many decades. And what we've seen is really encouraging. Just recently, there were two working groups established for the very first time within the NNSA among different offices, specifically looking at security by design and safeguards by design in these new reactor designs. And so one of the things I picked up on that Rachel mentioned was sort of, we don't want to advance progress against one threat while increasing risk for the other. And what I think we find ourselves in is a really unique moment and an opportunity, honestly, to sort of learn from some of the wrong ways we developed the sort of first and second generation of nuclear reactors, and how we can sort of go about this in a better way now. And what I mean by that is a lot of or in almost every of the first and second gen reactors that were built, designed and built, safeguards applications were sort of an afterthought. We were almost building the plane as we were flying it, if you will. And that could be really costly. If you design a reactor, you build it, and then you have to go back and look at how to implement security and safeguards after the fact. And so we're at this really great moment where almost all of the advanced reactor companies that I engage with, two of which are represented here today, have been incredibly thoughtful about thinking through security and safeguards with their reactor designs from the earliest stages. And so I'm very optimistic about seeing these different stakeholders and different communities come together now ahead of demonstrating these first designs. So I think that we're moving in the right direction there. There's definitely still more work that could be done, though. But Jennifer, to some of your other points in the question, I'll just touch on a couple different sort of moving pieces, as you mentioned, in the sort of advanced nuclear ecosystem policy space. And the first is one that Rita mentioned earlier and a few others have touched on, which is the Advanced Reactor Demonstration Program that was recently launched. So Congress made a strong bipartisan statement of support by appropriating $230 million for this program in 2020. And then just recently, the House Appropriations Bill for fiscal year 2021 continues this support with an additional $240 million. But what we really need to see is Congress enact legislation that codifies this program and commits to the funding needed to complete its mission. Because at the end of the day, we don't have a lot of time to get this right. And the demonstration program is going to pick really the two most likely technologies to be commercialized in the next 10 years. And so we're looking at around 2030. And this date is extraordinarily important because many countries, utilities, and manufacturers have plans to achieve net zero emissions in that time frame or out to 2050. And in the utility world, 2050 is just one investment cycle away. The average lifespan of a natural gas generator is 22 years. And plants that power industries like cement and steel production can run for 20 to 50 years with proper maintenance. And the industrial sector is one of the really most complex and difficult for us to decarbonize. So this means that net zero technologies really need to be fully commercialized by the mid 2030s, and they need to be backed by policies that support their deployment. So we really need to ensure that the products we're demonstrating through this program really feature things that the market wants. So we need cost competitive, able to integrate into highly renewable grids, and to replace fossil fuel plants and retiring nuclear plants. So really excited for the demonstration program. I believe the application period is closing now on August 19th. And what we really need in that area is, as I said, just to see this codified, we need legislation to pass that will ensure that we see the funding in the years to come to complete this process. And then I would also just speak briefly to the larger fuel cycle and supply chain. We absolutely need to establish a program to make high assay, low enriched uranium, HALEU, which many of these advanced reactor designs will need. We need to develop a program to make this fuel available for use in advanced reactors and on a timeline that matches early reactor deployment goals. And then I want to also talk a little bit about easing the path to market. We need to expand things like the current production tax credit and add new tax incentives for advanced nuclear. These can be investment tax credits that could be taken up front as cash, which the government used to rapidly deploy solar projects. There's a lot we can learn from the success we've seen in expanding solar energy here in the United States. We also can institute a pilot program for long-term power purchase agreements for early deployments of innovative nuclear technologies, with the potential for some reactors to receive a reasonable price premium to help offset the higher costs of initial projects. And we also need to ensure that there are smart export controls that enable international sales of U.S. advanced nuclear technologies, but balance the need to protect against non-proliferation, as Rachel mentioned earlier. And then also passing a comprehensive clean energy standard at the federal level that really values and signals that the carbon-free power produced by an advanced nuclear reactor will be valued. And then I'll just talk a bit about improved coordination across federal responsible for tracking, organizing, and improving communication between different projects and programs related to advanced nuclear within the federal government. We must maintain federal financing programs like the DOE loan program to provide a variety of financial instruments that reduce risks and barriers associated with deploying new technologies and make these programs easier to access and navigate. And we also could create a centralized resource that leverages national labs, universities, and private industry partners for facilitating international collaborations, managing projects, and ensuring compliance with federal regulations for export controls. And then finally, I'll kind of come full circle and talk a little bit about international engagement. So almost every country on Earth recognizes the threat of climate change and the fact that every single country on Earth will need to reduce its emissions to near zero by 2050 to limit global warming to a livable scale. But here's the thing. The richest and most developed countries on the planet are largely responsible for 79% of the emissions in the atmosphere that got us into this mess in the first place. And this is an important fact, and a fact that is not lost to the emerging countries being asked to transition their economies to clean energy. Just as many of them are finally making progress in growing their economies and addressing energy poverty. And energy poverty is an important term, and important to define and understand. The UN Sustainable Development Goal 7 aims to ensure access to affordable, reliable, sustainable, and modern energy for all by 2030. But only 5% of global energy consumption comes from residential electricity for things like lighting and the use of household appliances. So when you think about things like renewables and solar, they are wonderful, and we absolutely need to expand them. And they're great for making sure that poor communities and poor countries can keep the lights on at night and run household appliances and complete other domestic tasks reliably. But this is not what we mean by energy poverty. In order for a country